In this video, in the next couple of videos, we're going to talk about a chemistry technique called chemical analysis. And chemical analysis is a process that we can use to either identify the composition of something that we're starting with, or we can identify how much of something that we're starting with in a mixture. So there are two kind of big classes of problems we're going to work with here. One I'm going to call mixture problems. That's the one I'm going to talk through here. And in a mixture problem, we're going to start with a known substance that we want to know how much of that substance is in some other mixture. The second type is a combustion analysis problem, and in a combustion analysis, it's kind of the opposite. So we're going to know how much of some substance we're starting with, but we don't know what the composition is. So this first class, this is called a mixture problem. So we'll just do this example here. So in this example, I have a mineral, and the mineral is thenardate, and it has sodium sulfate in it, along with other inert compounds. And the inert compounds is important for us because the inert compounds just means that it's other stuff. It's not going to react with anything or interact with anything. So this here, this is a picture of thenardite. So this is our mineral, and this has the Na2SO4. So it's primarily Na2SO4. So in this mineral, you can imagine, I'm just going to say this blue. So this is our sodium sulfate in there, but it also has other stuff. And the other stuff, that's the inert compounds. So there's some of this colored stuff that's also in there with that sodium sulfate. They tell us in the problem statement that we know the mass of this. So that 0.123 grams, that's that total. That's the mass of the sodium sulfate and the other stuff that's in there. The problem's asking us to find the mass percent of the sodium sulfate in the mineral. So in this picture, I'm trying to find, right, how much of this blue stuff do I have relative to the whole thing? So our goal, the thing that we're trying to solve for here, so I'm just going to write this as a goal, is the mass percent of the sodium sulfate. And we know that mass percent is just the mass of the thing we're interested in. So we're looking for the mass of the Na2SO4 over the total mass we started with. And the total mass we started with is the mass of the thenardate itself, so the whole mineral here. So this is mass of the mineral. And to make it a percent, we're going to multiply by 100. So for this particular problem, this is the thing that we're trying to find. This is the goal that we're trying to solve for. So if we look at these numbers, I need a mass of Na2SO4, and I don't have that at this point, right? So this 0.123, this is the mass of the whole thing together. So this 0.123, this is actually this number right here. This is the mass that we're starting with. So this I know, this is known, this we need to find. And if I can find the mass of just the sodium sulfate, then we can plug into this formula here and we can finish this problem. So how are we going to find that number? So we want to look back up and think about what we have here. So again, in this mineral, we've got the sodium sulfate and we have other stuff. So what we're going to do is use a technique where we're going to take this mineral and we're going to dissolve it in water. And when I dissolve it in water, that sodium sulfate is aqueous, so it's going to dissociate. So I'm going to have an aqueous solution of that sodium sulfate. And this other stuff is going to still be in there, but it's inert, so it's just floating around. So in here, if you can imagine, there's my sodium sulfate dissociated as ions. Then I've got a little bit of that other stuff in there that's not going to do anything. So then we're going to take that sodium sulfate and we're going to react it with some barium chloride. So here's my barium chloride, also an aqueous solution. So that means I'm going to have barium ions and chlorine ions or chloride ions in here. And when I put these two things together, we can write this reaction out as a practice for what we did earlier. So I've got the barium chloride and my sodium sulfate. This is an exchange reaction, so I know I'm going to produce barium sulfate and sodium chloride. If I balance that, I'll have two of those sodium chlorides. We check our solubility charts. Sodium chloride is aqueous. Barium sulfate is solid. These two guys were aqueous over here. So if we look at this reaction, this is the thing that we want, right? We're trying to find the mass of that sodium sulfate, and we know that this is going to form a solid. So the great thing about that forming a solid is that when I mix these two things together, because it forms a solid, I have this precipitate. And that barium sulfate I can separate, so I can use filtration, use a funnel and some filter paper. I can pour this solution through that. I can collect all of the solid in that filter paper. And then once I dry it, I can measure the mass. And we can ultimately collect all of that barium sulfate, which means I have a mass of barium sulfate, which was given in our problem statement. So that's our 0.177 grams. So if we look at this equation, what we can see is that I have the mass of this. And if I look at this, all of the sulfate here had to come from the sodium sulfate that I started with. So if I have this mass, we can use our just general stoichiometry problem solving approach to take the mass of this to find the starting mass of this reactant. If I have the mass of this, that's what we're going to plug in as our top number here. So this is essentially just a stoichiometry problem that we're adding an extra step to make it a mixture problem, so that we can throw that back into our mass percent number at the top. So let's set this up as our stoichiometry problem. So we're looking for grams of Na2SO4, and we're starting with that 0.177 grams of barium sulfate. So this is grams to grams, so we know we're going to need 3 steps to solve this, and we're going to plug in our numbers. So first is the molar mass of the barium sulfate. So this is 233.4, and that's a molar mass, so we always have 1 mole on the other side of that. Then we do our mole to mole ratio. So up here in our formula or our balanced equation, we can see that there's a 1-to-1 ratio of these guys. So we have 1 mole Na2SO4 for every mole of barium sulfate. And then our last one is our molar mass of the sodium sulfate. So I have 142.05 and 1 mole on the bottom. Always good to go back and just check your units. So we had grams of this here, grams of that there, 1 mole of this, 1 mole of this, 1 mole of that, 1 mole of that, and we're good with grams of the Na2SO4 at the end. Plug all of that into our calculators, and we end up with 0.1077 grams of Na2SO4. And then again, this is the number that we wanted, so we're not finished yet because we need to take this number and we need to plug that back in up here to our goal problem, right? So up here, we had our goal was to find the mass percent. So I'm going to take that 0.1077 grams divided by the mass that we started with. This was our 0.123 grams, multiply by 100. And when we do that, we get 87.8%. And that would be the answer that we were looking for in this problem. So if we go back to starting, we know it's a mixture problem because I have something contained in a bigger substance, in this case, an ionic compound contained in a mineral. We're asked for a mass percent. So we identified our goal here as looking for the mass percent of the sodium sulfate. To do that, we need the mass of the sodium sulfate over the mass of the total. So we needed to find that top number there. We can find that top number by starting out and setting a balanced equation between the two things we're going to react, recognizing that all of the sulfate from the thing we're interested in ends up in the barium sulfate on the product side. Set up our basic stoichiometry problem to find that starting mass of sodium sulfate and plug that back into our mass percent problem.